Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In oxidative ozonolysis, the C is equal to C double bond is cleaved. Each carbon of the double bond is oxidized. A terminal is equal to CH2 group with 2 hydrogens on the alkene carbon gives formaldehyde, HCHO, under reductive ozonolysis, but under oxidative ozonolysis it gives CO2, since HCHO is further oxidized to formic acid and then to CO2. A carbon bearing 1 hydrogen on the double bond gives a carboxylic acid. A carbon bearing no hydrogen, I, R to C is equal to gives a ketone, which is not further oxidized under standard oxidative ozonolysis conditions, so no CO2 is produced from that fragment. Moving on to the next step. Analyze each option for terminal is equal to CH2 groups, which produce CO2 versus internal or desubstituted alkene carbons, which produce ketones, no CO2. A. Methylcyclohexane. Structure is cyclohexane ring with exocyclic is equal to CH2. The double bond is between the ring carbon, desubstituted, R to C is equal to and is equal to CH2, terminal, unsubstituted. The is equal to CH2 and gives HCHO under reductive conditions, which oxidize to CO2 under oxidative ozonolysis. So CO2IS evolved from option A. B. The structure shown appears to be 1-methylcyclohexane variant or methylcyclohexyl, methylene. Looking at the image, it shows a cyclohexyl group attached to C is equal to CH2, I, a terminal methylene. The is equal to CH2 terminal carbon again produces CO2 under oxidative ozonolysis. So CO2IS evolved from option B. C. 1,3-butadiene, H to C is equal to CH is equal to CH2. Both double bonds have terminal is equal to CH2 groups and internal is equal to CH groups. The is equal to CH2 groups give CO2 and the is equal to CH groups give CO2 as well, since CH is equal to under oxidative ozonolysis gives CO2 from the monosubstituted carbon. Actually each is equal to CH gives formic acid then CO2 and is equal to CH2 gives CO2. So CO2IS evolved from option C. D. Cyclohexene. The double bond is endocyclic between two CH is equal to carbons, each bearing 1 hydrogen and 2 ring carbons, i.e., each alkene carbon is CH is equal to with ring substituents on both sides. Under oxidative ozonolysis, cyclohexene gives a linear dicarboxylic acid, adipic acid, hook CH2, 4Cu. Neither alkene carbon is a terminal is equal to CH2, so no formaldehyde is produced and thus no CO2 is generated. The product is a dicarboxylic acid, not CO2. And for the final step, only cyclohexene, option D, does not produce CO2 upon oxidative ozonolysis because both alkene carbons are internal, each bears 1 H and 2 carbon substituents, yielding carboxylic acid groups rather than CO2. Therefore, the correct answer is D. Therefore, the correct answer is option D.